Hello viewers, welcome to CEC lectures. Myself Dr. Preeti Jagwani. I am from Department of Computer Science, Aryabhat College, University of Delhi. So here in this series of Introduction to Programming using C++, in our previous couple of lectures, we have seen what actually polymorphism, how polymorphism is being implemented in case of C++, and polymorphism, or more specifically I can say we were talking about static polymorphism through function overloading, and we have seen what is actually function overloading and what are the we can say benefits of function overloading. And in today's lecture we will see what will happen, or why we are using overloading with constructors specifically, and then towards the second part of the lecture we will be drilling down into some of the nitty-gritties of function overloading. So today our overall agenda will be constructor overloading and then some specifics about the function overloading concepts. So now in order to begin with, let us recall that when we are talking about overloading a particular function, that means the function name is same and we are having more than one versions of that function using the same name. They can have a different return type, but they must have different arguments. Those different arguments could be different number of arguments or different type of arguments. So in this situation we can say the function is being overloaded. Now let us try to understand what will happen if we are going to overload the constructor. So as you all are aware, constructors are specialized member functions of a particular class who are having the same name as that of the class with no return type, and these constructors are basically called whenever you are invoking or whenever you are creating a particular object of that particular class. Now if we can say overloading constructor, so what do you mean by overloading constructor is we can have more than one constructor in a class with the same name, and with the same name, that means if it is a constructor the name is same as that of the class. So more than one constructor function in a class, but these constructor functions must have different list of arguments. So again, in order to repeat, different list of arguments in terms either we can say different number of arguments or different type of arguments could be there, but there must be a different argument list. Now this concept is actually quite similar to function overloading. Now in constructor overloading, what will happen actually? Through the help of constructors we create the objects. So while creating the objects, arguments must be passed to let the compiler know which constructor is to be called or which constructor is to be invoked. So for example, I am having one class, let's say class 1. So one constructor, let's say class 1, that is having no parameter list. Another constructor having with the name class 1 is having one parameter, and the constructor 3 with class with the same name as class 1 is having a parameter list of 2 arguments. So whenever we are going to create the objects, these constructors will be invoked. So at that time argument must be passed in order to in order to make sure that compiler is well aware that which constructor needs to be called. In the sense, if we are just invoking an object without any parameter, that means the constructor with no parameters will be called. If we are invoking an object by passing one parameter, then corresponding constructor will be called. Or if we are invoking if we are creating an object with 2 parameters within the syntax in the bracket, that means the corresponding or the matching constructor is to be called. So while creation of object, arguments will be passed in such a way that the compiler will know that which constructor is to be called. Now point is, when we talk about function overloading, so function overloading is having kind of a specific characteristics, in the sense that why do we need overloaded function. So specifically when we are talking about constructors, so what all are the benefits of constructor overloading? So constructor overloading is going to give you flexibility of creating multiple types of objects of a class by having more number of constructor in a class. So as I have given an example, that one object will be created without any parameters, another object will be created with one parameter, and then the next object will be created having maybe by having 2 parameters or 3 parameters, depends on how are you coding it. So basically there is a flexibility of creating multiple types of objects. Now someone can raise a question that why do we need these multiple type of objects, or what is kind of a real life application of these multiple types of objects. So let us try to understand the concept of this multiple types of objects, which is achieved through overloaded constructor. Now let's say we are having a particular database, let's say music database, and what do we want to do? We want to allow users to access the song information, but here we are having two types of users. One is a default user and another one is a premium user. So while creating the object corresponding to default user, through which the user will be able to access the song information, so for default user we need some limited information, for example title, year and genre from the music database. And let's say for premium user we need the full information. That means we have title, year, genre, mood, tempo, etc. So now if we are creating a class music that is going to process the song information on the basis of above criteria, so how are we going to create that thing? We will say one constructor music with only let's say 3 pieces of information, which is title, year, genre, and this will be, we can say, a default user. And in case of a premium user we can have one constructor of this class music with the parameters which are different from the default users, and those parameters will be title, year, genre, mood, tempo, etc. So for premium users will be created on the basis of a different information, and kind of we can say default users are created on the basis of a different information. Similarly we can kind of let's say we are talking about a university kind of database. So in that university database we need to create two types of users. One is again a general user, and another one we can say an admin user. So if we are creating an admin user, we need to have some more information, and if we are creating a general user, we can work on bare minimum pieces of information. So in this situation, while creation of these two different users, different number of parameters are required, and these different number of parameter requirement can be easily satisfied with the help of the concept of overloaded constructor, or similarly we can say the music class which we were talking about. So the empty constructor music will process the music information for default of free users, while the overloaded constructor with a different parameter set, let's say music character pointer user, will process the premium user. So basically two constructors of this class music. One is kind of a default constructor without any parameter, which is for default users or free users, while for premium or paid users we have one more constructor of this class music as with the parameters character information user. Similar situation can help in the help of the university database. So this was actually the, we can say, just like the normal functions, we can overload the constructors as well. And then within the why this is required, because we can have flexibility of different type of users creation. Now it is it is not just the function overloading, which is actually a kind of, we can say, simple concept, but it can have some ambiguities if not handled very carefully. So we can have some ambiguities in function overloading as well. So let us try to understand what is the concept of ambiguity when we are talking about function overloading. So we can say a situation when the compiler is not able to take a decision between maybe two or more than two overloaded functions. So compiler is, in a way, I can say, confused that which function is to be chosen among these overloaded functions. So when this situation happens, or when this type of situation arises, this is known as an ambiguity. Now ambiguous statements, we can say, are actually the errors, and they will not allow the program containing that ambiguity to get compiled. So if a program is having ambiguity is nothing but those statements which are having errors, or in the situations where your compiler is not able to decide between the two overloaded functions. These type of statements will not allow your program to compile. So we have to be very careful that what are the statements which are going to give us the error, or what are the statements through which ambiguity can be can arise. So let us try to understand all these situations in which we can have some ambiguous function overloading, and the compiler will not be able to choose between the overloaded function, and as a result your program will not get compiled. So if we want to list down the causes of ambiguity, so earlier in the earlier lecture we have seen one cause of ambiguity wherever the name of the overloaded function is same and the parameter list is also exactly the same. The only difference is of return type. So this type of program is not going to get compiled, because just having the return type different will not help in overloading the functions. So that is one cause, we can say, just having the different return types in which the overloaded compiler will not be able to choose the proper overloaded function, and hence the program will not compile. Now another cause of ambiguity concerning with overloaded function is automatic type conversion, which is a kind of, we can say, a very important facility available in C++, but this facility, if not handled carefully, is going to give us ambiguity as far as overloading is concerned. So let's see how. So automatic type conversion, when we talk about, is actually an attempt to convert the arguments used to call a function into type of arguments expected by the function. Let me repeat it. So basically your C++ automatically attempts to convert the argument which are used to call a function, and these arguments under the umbrella of this automatic type conversion will be converted into the expected type of arguments which a function is expecting. So how? We are going to take this in a short while with the help of an example. So coming to example, let's see, we have a my function, my func, which is returning an integer. Return value is the integer, and the you have your parameter list is one parameter which is of type double. Now that is one thing, and somewhere in the program later down, if I am calling this my func with a particular character, and that character as shown on the screen has been passed with the in a single inverted comma, that means it is of a character type. So my func C, so I am calling this my func with C. So now what will happen? The prototype is actually looking for a value which is double, while in the C out I am passing a value, or while calling the function I am passing a value which is of character type. Now this will not be considered as an error, because C++ automatically converts the character C into its double equivalent. So this is what I was talking about, automatic type conversion. So this kind of automatic type conversion, which is actually a facility, may give you some error, or may give you some may introduce some ambiguity in case of overloading. Let's see how it happens. So here this is a conversion applied from character to its double equivalent, and as a user or as a programmer we need not to do anything explicitly about it, because this is a kind of automatic conversion, or we can say an implicit conversion. Now coming to these other types of conversion, very few type conversions of this sort are actually disallowed. So what I am trying to emphasize upon is these types of conversions are actually valid, or we can say are actually allowed, as we have seen. So but on one hand, as I was telling, that this automatic type conversion are convenient. They are kind of a we can say facility available to us as a programmer, but they can be a prime cause of ambiguity as well when we are talking about the overloaded functions or overloading constructor, or when we simply talk about the overloading thing. Now let's see how it is going to create an ambiguity. So in order to show or in order to see why these automatic type conversion, or how these automatic type conversion are going to raise an ambiguity and or going to raise a situation in which your program is not going to get compiled, let us see an example. So here we have hash include iostream, which is, and then using namespace standard, these two kind of standard we can say statements. Then please notice we have two definitions or two prototypes of the function myfunc. So one is returning a float and expecting a float as argument, and another prototype is actually returning the double value and expecting the double value as well. So one is returning a double, expecting a double, and another one is returning a double and expecting a double in the argument list. And this is basically why, because it is having the same name, we can say this is an kind of overloaded function. And in main, what is happening? In main, I am actually calling these two versions. Now see what is happening. If I am saying cout myfunc 10.1, one call is that, and another call it cout myfunc with 10 along with a return 0. Now before going into the ambiguity, let us try to see what these functions are doing, because in this program till this point we have just seen the prototype, but the actual definition of this myfunc with double and myfunc with float is actually nothing. We can say it's just a simple function. We can say myfunc is returning the variable, and similarly double myfunc is returning the negative of that variable. So that's what the I can say definition of this my function is. So the float version is returning the variable, while the double version I can say is returning the negative of that variable. So with this definition, now let's see what is happening. Inside the main I have returned cout myfunc 10.1. Now this is actually an ambiguous call, because of passing this 10.1, this is automatically going to call the double version. That's fine. So compiler is very clear here. But if we are talking about cout myfunc 10, now this is going to give rise to ambiguity. Now why this is going to give rise to ambiguity? Because here we have simply passed an integer. Now that integer can be converted into float, or that integer can also be converted into double. So now your compiler is confused here that which version is to be called when you are passing just the value 10. Do it need to call the float version or double version is to be called? So when we are calling the first function with 10.1, which is a double value, we can say, so there is no ambiguity. So unless explicitly specified as float, and how do we specify float? We specify float with the help of an kind of f. So 10.1 f is pretty clear that it is calling a float, but here 10.0 f or something like that is very clear. But if we are saying just 10, it will unless explicitly specified as float, all floating point constants in C++ are automatically of type double. Hence we can say the call is ambiguous. That means whenever we are saying my func10, your compiler is not able to decide here which particular this thing is to be called, which particular version is to be called. So in case of my func double, as we have not explicitly specified as float, these floating point constants will be of type double, and hence double version of my func will be called. But when we are calling it with a integer, ambiguity is introduced because the compiler has no way of determining that whether it is going to call a float version or whether it is going to call a double version. So in the second call, whenever we are saying my func10, this will cause an error message to be displayed and the program will not compile. So let's try to recap it once more. So my func 10.1, we have not specified any f here, so automatically this is going to call double. Now why this is going to call double? Because of the sole reason that we have not specified any f here, but this is going to make it very crystal clear call that double version is being called. But whenever I am talking about my func 10, that means ambiguity is introduced here because the compiler has no way of knowing whether it should be converted into a float or to a double, because 10 is simple and integer. Conversion of integer to float is also possible, and conversion of integer to a double is also a valid conversion. So now your compiler is confused here that which version is to be called, because there are two different versions. One is with a float and another one with a, I can say, double. So this causes an error message to be displayed and the program is not going to compile at all, because compiler is not able to decide between the two versions that which one is to be called. Now please try to understand one thing which is very important here is, actually this ambiguity is not because of overloading. It is not the overloading of my function which is going to create the ambiguity. Actually it is related to the ambiguity, or the kind of, we can say, the problem is related to that double or float. So basically what I can say is, it is the specific call to a particular my func call using an indeterminate type of argument that causes the confusion. It's not about overloading, it's about what type of argument you are going to pass. That argument, if not we can say, if not determined completely, or if not determined in an error free manner, that is going to create a confusion. It is not about overloading, it is about indeterminate type of an argument, or basically we can say, or in putting it in other words, we can say the error is not caused by the overloading of my func, but it is about an specific invocation of a particular automatic type conversion. So here what we have seen in this lecture is actually what constructor overloading is, what are the benefits of constructor overloading, and we have seen one example of the kind of introduction of ambiguity which is introduced with the help which is introduced because of automatic type conversion, and that ambiguity has to be taken care while we are overloading the functions. And here is a list of references which is actually being used while preparing this lecture. Hope you have enjoyed the lecture. Thank you.